Hello there, Mr. Sutton here, bringing you this AB Calculus 310 lesson on derivatives of exponential functions. In this one, we will be finding derivatives of exponential functions, including e to the x, and we'll also figure out how fast a fluid is spreading after a certain amount of time. We're going to start this one off with a rule for finding derivatives of exponential terms. So here is the rule. If you have b to the x and you want the derivative of that, you just rewrite that exponential part times the ln of the base. So with this rule in mind, pause the video and take a sec to find the derivative of e to the x. All right, let's see how that went for you. So following this rule, it's just going to be e to the x, because you have to rewrite the exponential part, times the ln of the base, which is e. But why stop there? I mean, what is the ln of e? That's 1, right? So the derivative of e to the x is actually just e to the x. This is not a typo. E to the x is its own derivative. Pretty cool. With those rules in mind, pause the video and try out this first example. All right, so going from left to right, just differentiating one at a time. This first one is a non-base e to x, so that's going to be 2 to the x times the ln of the base, ln of 2. Next, we have an e, so we're just going to have 3e to the x. E is its own derivative. And then finally, this one's a little bit different. This is actually not an exponential term. This is a variable to a constant, so we're going to just use the power rule on this one. So we just multiply -6 by e, and then we have x to the exponent minus 1, so this is going to be e minus 1. Here's another example. Pause the video and try this one out. All right, so on this one, you could use a chain rule, but a much easier way would be to simplify your exponents first. So we can rewrite this with a fractional exponent. This is really e to the 5x over 3, or just 5/3 x. And now to take the derivative of this, this is going to require a chain rule. So we have e to the something to the 5/3 x times, now we need the chain rule for functions inside the exponent here. So derivative of 5/3 x is just 5/3, which we can put out front if we want. Here's another example to try out, and see if you can do this in a clever way. Pause the video, give it a shot. All right, so here's what I mean by clever. Now, you could just launch into a chain rule on this one. We have e to the something, and then we have ln of something. However, you can sometimes use exponent and log rules to avoid using the chain rule. For example, e to the ln, we know those things normally cancel out. So we could just rewrite this as y equals pi to the x. And now this is just a b to the x kind of rule. So y prime is just going to be pi to the x times the ln of the base, ln of pi, and we're done with this one. This next one's going to require a little more work. Pause the video and give it a whack. All right, so we've got the product of two things. That's kind of the outer thing going on. So we'll use our product rule, u prime v plus uv prime, and I'll use the box and ribbon to organize everything. I have my factors of x cubed and e to the sine of x squared. X cubed, that derivative is going to just be 3x squared. And now for this one, we're going to have a double chain rule going on. First, we've got the outer function, e to the something. Well, the derivative of that is just e to the same something, so e to the sine of x squared. Next rule in, we've got the sine of something. Derivative of that is cosine of something, so cosine of x squared. And then finally, we have the derivative of the innermost function, x squared, which is going to be 2x. All right, using the ribbon to put it all back together, we've got 3x squared times e to the sine of x squared, plus x cubed times all this stuff down there. So there you have it. So at this point, you might be thinking, well, we haven't done a quotient rule. We haven't done something where we have to plug in a number or a real-life problem. We're going to do all that on this last problem. So flu in a school is spreading according to this logistic function, where p is the number of students infected after t days. We want to know how fast the flu is spreading after 3 days. So essentially, we need p prime of 3. Pause the video, try it out. All right, so first we need to find the derivative of this in general. For that, we will need the quotient rule. So I've got my box and ribbon here, and I've got u prime v minus uv prime over v squared going on, kind of hidden behind the scenes. So my numerator, we've got 100. Denominator, 1 plus e to the 3 minus t. Derivative of 100 is just 0 because that's a constant, so that'll work out nicely. And over here, this is going to be, let's see, 1 gets differentiated away. We've got e to the 3 minus t times negative 1, because the derivative of this negative t here. So negative e to the 3 minus t. Using the ribbon to multiply all that out. Actually, let's plug numbers in inside the box, right? That'll make it a little easier. So if t equals 3, what do each of these parts equal? 100 is still going to be 100. Now we've got 1 plus e to the 3 minus 3. That's 1 plus e to the 0, which is 1 plus 1, which is 2. 0 is still 0. And this is negative e to the 0, which is going to be negative 1. Now we'll use the ribbon to put it all together. So we've got 0 times 2 minus 100 times negative 1. So plus 100 times positive 1, you could write that as, all over 2 squared. So we've got 0 plus 100, so 100 over 4, which is going to be 25. And that's the rate of change, so that's going to be students infected per day. This concludes our lesson on derivatives of exponential functions. Logarithms is next. Till then, Mr. Sutton signing off.